We often face many issues in the process of software designing. Many times, we even thought of a one-stop solution to all our problems. That is exactly how the Java design patterns came into existence. Hey guys, welcome to yet another tech enthusiastic video from Edureka, and today we will be discussing about Java design patterns. So without wasting much time, let us take a quick peek on the agenda for today's discussion. We shall begin with why exactly we need design patterns. Followed by that, we shall learn what are Java design patterns. Later, we shall look into the structure of Java design patterns. Then, we shall see the types of design patterns, and finally, an overview of Java design patterns. I hope I made myself clear with the agenda. Now, let us begin with our first topic. Why do we need design patterns? We need Java design patterns to provide easy to recognize and use object-oriented programming solutions to common problems. They are inherently easy to maintain as many developers are familiar with them. In some other cases, the pattern is also a way to deal with the inefficiencies of a programming language. So our next topic is, what are design patterns? Software design patterns can be defined as a software template or a description to solve a problem that occurs in multiple instances while designing a software application or a software framework. Now, let us deal with the structure of design patterns. Structure of any design pattern is considered to be highly organized. They are often documented in the form of a template such that the users can visually identify the problem and instantaneously find a solution to it based on the relationship between the classes and objects. The design patterns template described by the original authors of the design patterns are as follows. The first one is pattern name and classification. Pattern name specifies the essence of a pattern. A good name is a key as it will become a part of our design vocabulary. Coming into classification, it specifies the type of a particular pattern. The second one is intent. Intent can be defined as a short statement that tells us what the pattern does and which design issue or the problem the pattern addresses. The next one is motivation. Motivation can be defined as a scenario that illustrates a design problem and how the class and object structures solve that problem. The scenario will help us understand the abstract pattern definition. The next one is applicability. This specifies in which situations a design pattern can be applied, what are the examples of poor designs of a pattern can address, and how to recognize these situations. The next one is participants. The classes and objects are the entities participating in a pattern along with their responsibilities. The next one is collaborations. Collaborations describe how the class and objects collaborate with each other to carry out their responsibilities. The next one is consequences. Consequences tell us the costs and benefits of using a certain pattern. They also tell us which part of the system can be changed independently. The next one is implementation. Implementation specifies what techniques we should be aware of while implementing the pattern and also tell us if there are any language specific issues. The next one is sample code. The sample code fragments are the ones that tell us how to implement a pattern in Java. Known uses. Known uses can be defined as an example usage of a certain pattern in real world problems. And the last one is related patterns. Related patterns specify which other patterns are related to this particular pattern and what are the differences between the both. With this, let us get into the types of design patterns. Java design patterns are typically divided into four categories. They are Creational Design Patterns, Structural Design Patterns, Behavioral Design Patterns, and JEE Design Patterns. Let us discuss each one of them in detail. The first one is Creational Design Patterns. Creational design patterns are concerned with the method of creating objects. They are preferred during the process of class initiation. The creational design patterns are further classified as follows. They are Factory Design Pattern, Abstract Factory Pattern, Singleton Pattern, Prototype Pattern, Builder Pattern, and Object Pool Pattern. Let us discuss some of the important creational Java design patterns practically. The first one would be Factory Design Pattern. The factory design pattern follows the principle of define an interface abstract class for creating an object, but let the subclasses decide which class to instantiate. The factory method is also known as a virtual constructor. The advantage of factory design pattern is it is designed to allow the subclasses to choose the type of objects so as to create them. Let us deal with an example of factory design pattern. Let us assume that we have three cellular network plans which describe the call cost per minute. Here we have three different networks, namely ABC network, PQR network and XYZ network, along with their charges per minute. Let us find out the cost of a certain number of minutes on each network. So this is the UML diagram for our example. Now let us execute this practically. As you can see, we have begun with our factory design pattern example. Here we have the first network, which is the ABC network, and similarly the PQR network and XYZ network. All of these networks have different costs for their plans. Now let us execute our factory design pattern to find out the cost of each and every network for a particular number of minutes used. So this is our factory method. Now let us execute it. As you can see, the console is asking us for the network we want to use, and we have three networks here. Let us choose ABC network. Now we shall try to insert the number of minutes we require. Let us take 35 minutes. As you can see, the ABC network will cost us 52.5 rupees for 35 minutes of talk time. Now let us deal with the next type of creational Java design pattern, which is the Singleton design pattern. The Singleton design pattern follows the principle of define a class that has only one instance and provides a global point of access to it. The class must ensure that only a single instance should be created and a single object can be used by all other classes. The major advantages of Singleton design pattern are it is designed to save memory and the object is not created on every request. Instead, a single instance is reused. Let us deal with an example related to Singleton design patterns. Let us assume that we have a MySQL database and we are trying to insert data into that database using one single instance. Here we shall have four different operations which will be performed upon the database, and all of those four operations will be using one single object instance. So this is the UML diagram for the solution to our problem. Now let us execute this code practically. So as you can see, this is the example for our Singleton design pattern. So this is the program for our JDBC connector, which will be connecting to our MySQL database. And this is a program for the operations which we will be performing on our MySQL database. Now if I execute this program will throw an error because I have a virtual machine on my system which will be using all the virtual ports. So before I begin this program, I need to switch off all the VMware ports. Here you can see that I'm switching off all the VMware tasks. Now let us start our MySQL and Apache. As you can see, both Apache and MySQL have been started. Let us start our local host. Now our local host is also started. So Edureka is our database which has the details of employees. Now let us try to insert new data into our database by executing the program of Singleton design patterns. Now let us execute this. As you can see, the program has been successfully executed and it is providing us four different database operations. Let us try to execute the first operation, which happens to be the insertion. To do so, I must be selecting the operation 1. Now let us insert the name of an employee. Now let us provide a password for the user. And let us designate an ID to the employee. The data has been successfully inserted into the database. Now let us try to view the data which we have inserted. The username must be Rajesh. As you can see, the name of the employee is Rajesh and his password is also being displayed. Now let us try to execute the third command, which would be delete. Now let us give the user ID which we need to delete. The data which we wanted to delete was Rajesh and his ID was 1011 and 01. Now let us try to execute the fourth operation, which is update. Now let us update the data of an existing employee in the database. Now we shall enter a new password to this user. As you can see, the data has been successfully updated. Now let us try out to exit this program. With this, we finish the execution of Singleton design patterns. Now let us deal with the next ones. The next type of design patterns are the structural design patterns. The structural design patterns deal with the composition of classes and objects which form large structures. They simplify the structure by identifying the relationship between the classes and objects. The structural design patterns are further classified as below. They are facade design pattern, bridge design pattern, composite design pattern, decorator pattern, adapter design pattern, flyweight design pattern, proxy design pattern, and lastly, the filter design pattern. Let us discuss some of the important structural Java design patterns practically. The first one would be the facade design pattern. The facade design pattern describes a higher level interface that makes a subsystem easier to use. Every abstract factory is a facade design pattern. The major advantage of facade design pattern is it protects the end users from the complex subsystem components. Let us deal with an example to understand facade design patterns in a much better way. Let us assume that we have a business plan and we are trying to purchase the franchise of one of the top food and beverages companies. We have McDonald's, Domino's, and KFC, and let us design a program based on facade design pattern to find out the cost of each and every franchise we want to buy. So this is the UML diagram of the facade design pattern. Now let us execute this code practically. So this is the code for one of the franchise, which happens to be Domino's, and the next one is the KFC, and the last one is the McDonald's. Now this is the franchise service registration code, and finally this is the client code. Now let us try to execute this program and find out the output. As you can see, we have already got the output, and this is asking for the franchise which we need to buy. Let us select KFC. As you can see, we have got the output here, and it says the franchise cost for KFC is 1 crore. Now let us deal with the next structural design pattern, which happens to be the adapter design pattern. The adapter design pattern provides an interface according to client requirement while using the services of a class with different interface. The adapter pattern is also known as a wrapper. The major advantage of an adapter design pattern is it is designed to enable two or more previously incomplete objects to interact with each other. Let us deal with an example of adapter design pattern where we have a simple library card example which is designed to issue a library card to a new user of a library which includes all the details like book holder ID, account number, and many more. Let us execute this adapter design pattern and see how does it work. So this is the UML diagram for our example. Now let us execute this practically. So this particular segment of code deals with the book holder ID, name, and account number, and the next one is related to the library card, and finally this code will give us the details of libraries such as library name, book holder ID, and many more. And finally the adapter class. This class is going to interact with all the other classes and get the details which we need. Now let us try to execute this code and see the output. As you can see, the library account holder name is being asked here. Let us input a library account holder name here. Now let us try to provide an account number to the account holder. Now let us give the name of the library. As you can see, the library card has been successfully issued, as it says the account number 201907 of Karan in MG library is valid and authenticated for issuing a library card. Now let us deal with the next type of Java design patterns, which happens to be the behavioral design pattern. The behavioral design patterns are concerned with the responsibility and interaction between the objects. These design patterns make sure that the objects are loosely coupled, yet can easily communicate with each other. The behavioral design patterns are further classified as below: chain of responsibility pattern, strategy design pattern, interpreter pattern, iterator pattern, mediator pattern, memento pattern, command pattern, state pattern, observer pattern, template pattern, and visitor pattern. Let us discuss some of the important behavioral patterns practically. The first one would be the strategy design pattern. The strategy design pattern defines the family of functionality and encapsulates each one and make them interchangeable. The strategy pattern is also known as a policy. The major advantage of strategy design pattern is It is designed to provide a substitute for subclasses. Let us deal with an example to understand strategy design pattern in a better way. We are going to consider a simple example of a calculator. We need to perform 5 different operations. Now we shall try to encapsulate all those 5 different operations into one calculator class and execute the program using strategy design pattern. So this is the UML diagram for strategy design pattern. Now let us execute this practically and see how does it work. As you can see, we have 5 different operations, which are addition, subtraction, division, multiplication, and modulus. We also have one interface, which is calculator, which all the other operations will be implementing. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed, and now it is asking for the value of the first one. Now let us similarly provide the second value. As you can see, the operations have been successfully executed on both the numbers, and the outputs for the same have been displayed. Now let us deal with the next behavioral design pattern, which happens to be the command design pattern. The command design pattern encapsulates a request under an object as a command and passes it to the invoker object. The invoker object looks for an appropriate object which can handle this command and pass the command to the corresponding object, and that object executes the command. It is also known as action or transaction. The major advantage of command design pattern is it separates the object that invokes the operation with the object that actually performs the operation. Let us deal with an example to understand command design pattern in a better way. This example demonstrates a simple command execution cycle where the user requires to exhibit switching on and off of the various electronic devices in his house like bulb, stereo player. He invokes the command using an invoker object called as simple remote control. Now let us see the UML diagram of this example. As you can see, we have 2 different electronic devices in the home, which are light and stereo. Now let us try to execute this program and see how does it work. So as you can see, this is our code, and the first one is our interface, which is command, and this is the code for light. Now this happens to be the command for executing the light operations. The first one is light on operation, and the next one is light off operation. Similarly, we have a class for stereo, which functions for on and off as well. The first one is stereo off command, and the next one is stereo on with CD command. Now let us try to execute this remote control operation and see how does it work. As you can see, the remote control has been successfully executed and the lights are switched on and the stereo as well. Now let us move on to our next design pattern, which is the observer design pattern. The observer design pattern defines one-to-one dependency so that when one object changes state, all its dependents are notified and updated automatically. The major advantages of observer design pattern are it illustrates the coupling between the objects and the observer. It provides support for broadcast type communication. Now let us deal with an example to understand observer design patterns in a better way. We are going to execute a program using observer design pattern to display the current average score and the current predictable score of a cricket match. This happens to be the UML diagram for the observer design pattern. Now let us execute this practically and see the output. As you can see, we have the first class, which is the cricket data, which happens to be displaying the current score display and the average score display. And the next one is related to the average score display, which calculates the runs and gives us the score. And now let us try to execute this program. As you can see, the output has been successfully displayed. According to the data provided to the program, it displays the data as 10.2 overs are already played, and the average run rate is 8.8, and the predictable score according to this run rate would be 441 runs. Now let us move on to our next design patterns, which happens to be the JEE Design Patterns. The JEE Design Patterns are concerned with providing the solutions to the Java EE based software applications and frameworks. These patterns are widely used in Spring. JEE Design Patterns are further classified as below. They are MVC Design Pattern, Dependency Injection Pattern, DAO Design Pattern, Business Delegate Pattern, Intercepting Filter Pattern, Service Locator Pattern, Transfer Object Pattern. Let us now discuss some of the important JEE design patterns practically. The first one would be MVC Design Pattern. The MVC Design Pattern is defined as follows. Models. Models are basically used as blueprints for all the objects that are going to be used in the application. The next one is views. The views are used to represent the presentational aspect of the information and the data located in the models. And the last one is controllers. Controllers control and act both as models as well as views. They serve as a connection between the models and views. Controllers are capable to instantiate, update, and delete models. They load them with information and then send the data to the views to present them to the end user. The major advantage of MVC Design Pattern is it supports multiple views of a particular model. Let us deal with an example to understand MVC Design Pattern in a better way. We are going to use the MVC Design Pattern to set and print the data of the students of a particular school. So the UML diagram for this particular example is as follows. Let us try to execute this practically. As you can see, this particular code segment is related to the student, which has the roll number and name of that particular student. Now this particular code segment happens to be the view of the MVC Design Pattern, and this particular code segment happens to be the controller part of the MVC Design Pattern. Now let us execute this design pattern and see how does it work. As you can see, the program has been successfully executed and the output has been displayed. According to the input provided, the students are Karan Kumar and Sandeep Shukla, and relatively their roll numbers are also displayed. Now let us deal with our last design pattern in JEE Design Patterns and see how does it work. The last one in JEE Design Patterns is the DAO Design Pattern. The DAO is a pattern in which the objects are dedicated to the communication with data layer. These objects instantiate session factories and handle all of the logic behind communicating with the database. The major advantage of DAO design pattern is it uses common calls to retrieve the objects. We shall deal with an example to understand DAO design patterns in a better way. In this example, we are going to display the developer details of a certain IT company using the DAO design pattern. The UML diagram for our example is as follows. Now let us try to execute this practically. As you can see, this particular class is a developer class, and similarly we have an interface called developer DAO, which will be implemented by the other classes of this program. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and the data has been displayed, and according to the details we have provided to our developers, the name of the first employee is Kushagra and his developer ID is 0, and the second employee is Vikram and his developer ID is 1. As you can see, we have also provided an update operation inside the code, according to which we have updated the employee Kushagra with Lokesh and provided his ID to the new employee, which is Lokesh. Now with this, we should move on to the next topic, which is the overview of design patterns. The Java design patterns are designed to be reusable in multiple projects. They furnish solutions that help to define system architecture with ease. Java design patterns are capable to capture the software engineering experiences. They provide transparency to the design of an application. And finally, Java design patterns provide clarity to the system architecture and provide the possibility of building a better system. With this, we come to an end of this session. I hope you have understood Java design patterns, their types, importance, and their implementation through some real-time examples. If you have any queries related to this session, then please feel free to write them in the comment section below. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!